Okay, I think we will get started. Good morning, everybody. Welcome to our talk, Jnario, Executable Specifications for Java. I'm Sebastian Benz. I'm working at E.S.R Labs, which is a new startup in Munich. We're doing mostly here embedded systems development and tools for embedded systems. And this is Birgit Engelmann. She's working at BMW Carity, and together we've been developing Jnario over the last year. The whole thing started basically when I realized that a certain way to write your tests really helps you to design your system. And the idea was quite easy. Like, you take the name of what you want to test. In this case, it's a customer lookup. And then you make little sentences with your test names. For example, the customer lookup finds customers by ID, or the customer lookup fails for duplicate customers. I mean, this is a really intuitive way to describe the behavior of your classes or your program. And I realized that this really helped me to focus my development, because as soon as I started to, when the names of the tests got too complicated or too long, then this is a good indicator probably that it doesn't really fit what you're testing, the behavior, into the class. For example, in this case, customer lookup. So this might be a good indicator then to move the behavior into a separate class or something like that. So it's a really good way to describe your application. And now if we look at it and remove all the Java noise, and then we will end up basically with a little list of what the customer lookup is doing. And it's basically, if you look at it, it's an executable specification because it describes the behavior. Everyone can read this. At the same time, you can run it in your build and ensure that your application fulfills the expected behavior. Another example is, here we have a test for a resource set, an EMF. And the test is called Loading Resources by File URI. And I mean, the test is quite trivial. It shows some basic EMF behavior. So given we have an echo file on a certain path, we create an URI, then a new resource set, and load the corresponding resource. And then we make an assertion, for example, that the contents of the resource are not empty. Now again, I mean, if you look at it, it's also a great example on how to use the EMF API. And for example, we could again strip away all the Java syntactic noise and just like put it into a document, for example. And yeah, we have a pretty good documentation for our API. So basically, the second thing is that tests are also kind of like executable documentation. And the great thing about this is they are run with every build. And your documentation, like the examples, will always work because you prove that in your tests. And when we look at it, we have seen that tests can be two things. The first thing is they can be executable specifications. And the second thing is that they also can be executable documentation. And I don't know about you, but you might now think that, yeah, might be, but I'm using JUnit, and it's like, this is not really supported by JUnit. I mean, there are some tools out there, but it's really difficult to use your tests in this way. And that's also what we've been thinking. But now we've got such great tools as Xtend and Xtext to build our own languages that are fully compatible to the Java type system. You got Java expressions that you can write. And this is when we realized, okay, now we can do something about that. I mean, if we look about and on other languages like Ruby or Scala, they have really great testing frameworks like RSpec, Cucumber, or Specs. And now we can do the same for Java by building a DSL specifically designed to make tests more expressive. And this is what Jnario is. It's a DSL for testing, and it's based on Xtend, so you get all the goodness you get from Xtend, like lambda expressions, the switch statement, multi-line strings, and things like that, which are really useful when you're writing tests. you also get them in Jnario. The other thing is that you can, that we have one language which you can use to write business readable acceptance specifications, which are a great way to communicate with your customers. But also, like, I mean, these are really good when you describe the system from an outside perspective, but inside, like when you're implementing your implementation, we also have a different language which is really good for writing succinct unit tests. And finally, you're able to generate executable documentation which looks really good from your specifications. And today, we would like to show you Jnario, and we will do this by developing an example application using Jnario. And we will use an approach which is called outside in. So we will start from an outside perspective. We describe what the expected behavior is from a customer perspective, and then go in and add the missing implementation so that our application will work in the end. And today we're going to implement a coffee tracker, which is a really nice tool for tracking your coffee consumption as a developer. And yeah, Birgit will start and show you how you implement such a system using Jnario.
So let's get started. Of course, we want to use Eclipse. And what we start out with now is just a plain Java program. So let's create a Java project, and we want to create a coffee tracker. So what happens now? Well, you start out and you have stakeholders who say, okay, we want to have a coffee tracker. So what do you do as developer? Usually you go and talk to those persons because you want to know what are the requirements, what features do they want to get. And usually you write it down somewhere in some tool or whatever. But it's pretty nice to actually have it together. And this is the first part that's possible with Jnario. So we have these feature files. And there we will now define some features. We will create a source folders for all our specifications, have some package for the features, and first we want to have a feature for the coffee tracker, and the name should be that we want to track the coffee consumption. So what comes up now ist das File. Warum gibt es das andere da? Moment. Yeah. The project was still, yeah, we didn't delete all the contents, so let's start over again with a really empty project this time. Sorry about that. So, again, coffee tracker. And we create a new feature file. Okay, this time it's specs again, package features, coffee tracker, and tracking coffee consumption. Damn it. Sorry about that. First, of course, we need the source folder, else it won't work. Specs, features, coffee tracker, tracking coffee consumption. All right. So we get this feature file. You have up here the package, you have here the keyword feature, and everything else here is just plain text. You can write behind the feature whatever you want, just readable for everybody. And we get an error here because we have to include some Jnario libs. We have just a quick fix for that, and then everything is fine. What you saw now is that this folder here came up. And actually, since we're using extend, everything we do is generated into plain, simple Java files. So everything you write in a feature file and later in the specs files will be generated to Java, so you can use it with all existing Java code that you have. So there's no problem with just using existing stuff. All right. So you have this feature, and then you talk to the stakeholder, and he says, okay, we want to track our coffee consumption. So let's just write this down as documentation of what the feature should be. In addition, it's always important to know who your stakeholders are. So does some controlling person who wants to create a bill use this tool, then she might want to have a nice UI or something. But if it's just a developer who wants to track something, he just might do it in a plain text file. So it's always important to know who you are developing for. So we should also document this as developers who need their caffeine. What's also really important about features is that we don't start gold plating, that we don't go ahead and say, oh, I have this idea, and let's add all this, and the stakeholder is like, yeah, but I absolutely don't need this. It's just not necessary. So we always need to have a benefit for a feature. So we should also document this because it's important. So in order to watch our expenses, because we don't want to spend too much money on coffee, there's still other stuff that we might want to buy. So we write this down too. And what we get there is a narrative, and you might recognize this from the agile development. It's called user stories. And this is just a reminder for conversation. So not everything is specified in there. It's just to know who you have to talk to actually find out everything that is necessary for developing this feature. So now as a developer, you know what you have to do. But then there's the question, when are you finished? Like, at what point are you done, and when is the stakeholder satisfied? And the stakeholder might also want to know at what point in time everything he wanted is finished. So what you do is you go ahead and define this acceptance criteria. And this you usually do in the form of scenarios. So now we want to define scenarios. There's a nice quick fix to create a scenario. And, well, first of all, we want to know the overall coffee consumption. So we have different people, and we want to know how much everybody drinks. And then we might have another scenario saying we want to know the coffee consumption per person. All right. So as you saw, there are some keywords, feature and scenario, for example, but everything else is just plain written text, and you can write whatever you want. So how do you define what happens in a scenario, so what is necessary? And this is where we orient ourselves on tests. In tests, you have a setup, then something happens, some action, and in the end, you verify whether or not this was the right outcome. And this is also what you do in scenarios. What you define first is the context, and there's this given keyword, and well, what do we need to actually work there? So we need some list where the coffee consumption is recorded. So given the coffee list, and now we want to define this list. Let's say it says that Sebastian drank 3 coffees, and I drank 2 coffees. And what we need, of course, is a coffee tracker, so some application who actually does something with this list, so, and a coffee tracker. So now, what should it do? Well, when I get the overall consumption, then the result should be 5, of course, because there are 5 coffees drinks. And this is still just written down text, so everybody can read it, your stakeholder can read it, but now we want to make it executable. And first of all, I will implement this scenario quick. And what's nice here is you have auto-completion, and you can just use steps you define somewhere else in a different scenario or in a different file or wherever. So let's define again a list. So, and we need a coffee tracker. The when is this time different. When I get the consumption of Sebastian, then the result should B3. Okay. So what we see now is, again, when I save the stuff over here, there are some files generated. So for each scenario, there is a file generated, and in there are methods for every step that we defined, the given when then steps. And this is actually already executable as a JUnit test. So since it's compatible with Java, we just create classes that run with JUnit. And what you can see down here now is you find again all the definitions, so you find the feature and the scenarios in the hierarchy. And it will tell you, well, there were no errors, but I ignored 8 steps, so you're not done yet, because you actually have to implement the stuff. And this is what we will do now. So here comes the implementation, and this you will just do behind the step definition. In this case, we use Xbase. It comes from the Xtext guys, which is this nice expression language where you can write pretty concise expressions, but everything you use in here can be Java files, so it's all compatible. All right, so we start out with this list, and what we probably want to get in the end is some list of coffee drinkers. So what happens now is you actually start to flesh out your domain model. So you think about, okay, I might need some coffee drinkers somehow, and later I probably need a coffee tracker. So you start to define all those domain aspects, basically. So of course there are errors, but I have to define a name. Coffee drinkers. Okay, so let's just import Java util. So all the import statements and quick fixes also work in here. And then, of course, no coffee drinker exists yet, so let's create this one. You can either create a Java class, or I will do an extend class, because I don't want to write that much. So let's put it into the source folder and create some packaged coffee. Okay. And let's go back to the feature, and we have to just import it now. Okay, so you define this coffee drinker, and then, of course, somehow we need to get this list into this list up here, into this list, so we need some kind of parser. So let's create a new coffee list parser. And this one should be able to parse what is given up here. And as you saw before, I used the syntax, because this is a multi-line string that is actually accessible in your code down here. So what happens is it generates this args variable, and you can access all the arguments that are defined in the step. Since there can be multiple ones, we will get the first one in this case. So of course there are errors, so let's just create the necessary classes. And in here, we want to define a method parse that returns coffee drinker, and which takes a string as input. Okay. Right now, I'm not implementing anything in there, because the first step, of course, is to get a compiling feature. So, all right, next step. Now we need a coffee tracker. So we want to define a coffee tracker that actually takes this list from up here as an input, because it has to be initialized with something. So let's parse in the coffee drinkers. Again, class doesn't exist yet, so let's just create this one. Okay, what I want to have in here is, as a field, we want to save the coffee drinkers. And there's this really nice annotation from extend, which actually creates an immutable class for this file now, and it will create a constructor which takes in all the fields and will generate the getter classes, so I don't have to define a a constructor in here because it will be generated for me. So let's import this one. And now there's still an error because it doesn't know the coffee drinker here. It says the method or field is undefined. And the reason is, as you know from Java, we have classes and methods, and if you define variables and methods, they are not visible to other methods. And this is the same here. So a scenario is basically a Java class, and each step is a method. So if we want to have variables visible in another step, we have to move the definition to up here. So you can define, after a scenario definition, variables that are visible for all the steps. So now it's blue, and you can access it. Okay, let's continue. So we will probably need coffee tracker in the next step because we want to access it. So we will put it up here too. Define the type. Okay, and make this the variable up there. And so we want some result that should be coffee tracker dot overall consumption. So we have to define the result, and we have to create this method. And there's also a quick fix which will generate a method in this class, and I would just have it return -1. Back to the feature, and we want to say that the result should be 5. There's this nice arrow annotation to say something on the left side, an expression on the left side should be something on the right side. So we say it should be 5. And since we have redundancy in here, we can actually create arguments again and access this and use it down here. Because we later, as you can see here, we want to reuse steps that we defined up here and do not have to implement them over and over again. And as you can see already that the gray steps down here are actually references to the steps that were defined before. So you can just jump into the definition and see what the step down here does. So the nice thing is I only have to make this an argument. So it becomes gray because it recognizes a step from up here. And I only have to implement this step. So result should be coffee tracker consumption of. And again, we want to make this name here an argument because you might want to use different names. And again, it doesn't know the method. So we will just create the method so it actually compiles. Okay, so we run this again as JUnit test. And of course, since we didn't really implement anything yet in the classes, we will get a red result. You can see that it executes each step, so the creation and stuff, everything was fine. But of course, the check in the end doesn't work because we get the result -1. And at this point in time, we actually come to implementing the details of the classes, so the parser, the tracker, and everything. And this is something that the stakeholder doesn't really care about. And this is more for the developer. And in this case, it's not important that the stakeholder can actually read everything. So you can start mixing actual implementation with your documentation. And this is now what Sebastian will show you in the next step, how you implement the coffee tracker and the parser and everything.
Okay, so I mean, what we've seen so far is that we ended up like just creating an API from what we needed from it. So basically, we ended up having 3 different classes, and of course the scenario is failing, but now it's actually a really good track of our progress, because once our implementation is far enough, this will pass, and we know we are done. And the good thing is we know we've just did enough to fulfill the requirements at the moment. Now you might think, okay, so it's nice to have a readable representation here, but it looks a little bit messy, and your stakeholder probably will never be able to read it. So this is why we integrated this really nice folding feature. So if you just press this button, it will remove or hide all the code, so we will end up having really readable code that really just shows you the feature and hides all the unnecessary implementation details. Okay, but I mean, scenarios are really good to describe your system from an outside view, but when it comes to implementing a parser, for example, you don't really want to start writing scenarios. There you would just want to have a language that makes it easy to describe like more or less normal unit tests. And this is what we're having here. So I'm just now going to create a new spec, and I'm going to put them into a different package called specs, and the name and I'm going to test the coffee list parser. Okay, so this looks pretty much like a normal Java file, but the difference is here we don't have a class, but we describe something, a certain part of behavior. So we can describe interfaces, for example, or classes, or we can provide a full text descriptions. So, for example, parsing coffee lists. Okay, so, and what we do is, in these specs, we describe or we claim facts about our program. So, for example, one fact is that an empty string contains no coffee drinkers. Another fact might be a coffee drinker is specified by name, then followed by an arbitrary list of pipes. And the third fact is that multiple coffee drinkers are separated by new lines. I mean, we can look at this like a to-do list. I mean, it's just for me to keep in my mind what I still need to do in order to finish implementing the behavior of our class. And I can already execute it. So again, as a JUnit test, and we will see, it will just show you the description of our facts, but again, they are marked as pending, mean they don't have an implementation yet. Okay, so the next step is to actually implement these facts. And but first I want to show you something about Jnario and what features we included. So first, for example, I'm going to create two variables like x, which is a string hello, and y, which is a string world. And then I'm going to concatenate them, and I expect them to be hello world. And here again, I use the assertion operator, which is the arrow, which I really like because it really nicely describes. So I expect this expression on the left-hand side to result in what I write on the right-hand side. And if I execute it, you will see that it fails, obviously. But the really nice thing here is that it will print a detailed error message containing the value of each sub-expression. And so, for example, in this case, it will say, okay, x plus y was hello world, x is hello, and y is world. So you don't need to debug your test anymore, but it will print down all the values of all sub-expressions, which is a really helpful feature. And this is only possible because we have a DSL here, and we can enrich these statements with necessary information because we compile it to Java. But we also have like a more expressive way to describe assertions, so you can basically write should be, which has the exact same semantics as the arrow, but you can negate it, so it should not be hello world, which obviously will pass. And you can extend this. You can add your own keywords you can write down after should, which is a really powerful feature. So back to our example. So what we want to implement is, okay, so we pass an empty string, and then, it should be an empty list. And obviously, I need to create a method first. So you see, you can declare normal methods like you can do in extend, so to provide additional information in your tests. And here, I will just create a new parser, which is our coffee list parser, and then I'm going to pass the provided string. I'm going to change this into a char sequence because I will need that later, and then obviously have to convert this to a string. So see, now our example up here is running. We can execute it, and it of course will be fail because we haven't implemented anything. Now if we look at this, I mean, this expression here is actually really readable. So it says, okay, pass an empty string should be empty list. I mean, it kind of is redundant with the title up here. So what we can do is we can just hide it, remove this, and just keep our implementation here. And execute it again, and it will show the expression which we had written here. So it's really helpful because you can avoid additional redundancy between your description and your implementation. This, of course, only makes sense if your expressions are actually readable. But now we can start implementing our parser. So I will go here, and then, so the first thing is we just need to return an empty list. So we try to make as small steps as possible to really let the tests drive our behavior. So what I'm doing here is I'm going to create a result list, which is a new list of coffee drinkers, and I will return it. Run my test, it will pass as expected. So the next thing is, our next fact is that that the coffee drinker is specified by name followed by the list of pipes. I mean, here I probably end up having multiple examples, and there's another really nice feature in the language, which is basically that we include tables. So you can, for example, describe multiple sets of inputs and expected outputs using tables in the language, which is a feature which wouldn't really make sense in a normal programming language, but for a language just for testing, it's really helpful. So we say, okay, we have an input string here. We have an input string, and we have an expected name and the expected count of the coffees. Okay, the first example is really simple. I just want to provide a name without any coffees, and then of course I expect the name to be Sebastian and the coffee count is going to be 0. Okay, run it, and okay, nothing happened yet because I actually need to implement my fact. And the nice thing, it generates a field of type table, which I can iterate over. So I can iterate over each line in the table, which I will do using the for each expression and extend, which requires a lambda. And inside here, I can directly access the fields of our table. So I say pass input, which is going to be a coffee list, and I expect this list should contain a coffee drinker with the expected name and the expected count. So the nice thing about these tables is that we use type inference here. So basically you can write in here any expression you want. You can create objects, lambdas, or whatever. And the type of each column will be the common supertype of all expressions in the common. And then inside here in these expressions you can directly reference these fields. Okay, so now I see the coffee drinker is missing 2 values. So first I need to give him a name property and property called coffee count. Again, I'm going to make it an immutable data class, so it will generate the constructor for me. Now, when I execute my spec, it will fail, and the nice thing, it will print the table inside of the error message, and will show a little X indicating this one failed, and down here you can read the reason why it did fail. So now we need to fix this one in our parser. So I'll quickly jump over here. And basically, what I will do is I will add to the result a new coffee drinker, which I will create from the input string. So in here, I will create this method. It expects a string. And basically what it will have is a name, which I'll make it easy at first. I will just assume that the input contains the name. And I will have the count of coffees, which will be null. And then I will just return a coffee drinker with the name and count. Okay, we run our tests. Our table passes now, but the first one is failing because we don't handle the error empty string case yet. So we quickly need to add an expression. So we say, okay, if the input is empty, then we will just return an empty list. Run again, passes. Of course, I mean, we are not done yet, so we need to add some more examples to our tables. So the next one will be, I actually will add a coffee count, and then I expect the count to change. Run my test, it will fail, and again we see here, it will print all the lines, show which one passes, and the other one will mark them as failed. So we go back to our parser and make our test pass. So I will just again make it really easy. So I will get the position of the first pipe, which is the index of the first pipe in our input string. Then if we don't have any pipes, so no coffees are counted, we have to check for this case. So if it's bigger than -1, then we will change the name by creating a substring of the input until to the first pipe. I have to make this a mutable variable. And the same for the count. The count will be the length of our input string minus the length of the name. Okay, so run it, it will pass. Of course, it's, again, a really simple example, but now I know, okay, so I'm probably going to want to have some white spaces here, so I will add in, and of course our parser is not good enough yet for this, so I will quickly trim this one, run again. Okay, I think our parser is already pretty good, but I'd like to add a different example with a different name and a different coffee count just to be sure. So this case should be 3. Run, and we are passing. So basically now we've implemented the basic logic to pass a single coffee drinker. So the first 2 facts are already passing. I mean, the whole idea behind this is you make false claims about the behavior of your program, and then you change the behavior of your program to make these claims true. So what I think it's a really nice metaphor about it. It's from Brian Merrick. And now we have to implement the last fact, which is multiple coffee drinkers are separated by new lines. So now we actually have to provide a proper example with multiple lines. I'm going to use the extend multiple line strings, which are really helpful for writing tests. So, and Birgit's going to have 3 coffees. And another nice feature in extend, I can also don't need to use call methods in the normal way, but I can also use them as extension methods like I do here. So it's basically the same method we're using before, but it will automatically pass the expression on which I call my method as the first argument. And then I expect the result list size to be 2. Run it, it fails, and quickly implement it. Now we're going to do some, you also see why extend is a really great language. So what I'm doing is I will take the input and I will split it by new lines, which will result in a list of string, 1 for each line. And then I will map each string to the created coffee drinker by calling the corresponding create coffee drinker method. And yeah, that's basically it. And now I can run it and it passes. So this is really concise syntax, like you usually know from functional programming languages. Okay, so we are done for the moment. We've implemented our first unit, and basically you've seen here, this is the exact use case you normally would use JUnit for, but it's, at least in my opinion, a lot more expressive, and you're a lot faster. Before I continue with implementation, I will show you another feature, which is test suites. I mean, you always want to structure your tests according to certain criteria, so you want to execute them together and so on. And yeah, we also created a language for this, so we will create a Jnario suite, and we will call it, it's going to be like the main suite for everything, so I will call it tracking, or no, just call it coffee tracker, like our app. And if you look at it, it looks like a text file. If you know Markdown, which is basically a wiki style, it's exactly the syntax. So this is basically the heading, and now I can reference my specs. For example, here I'm referencing my feature, and I can also, which is really helpful, I can write regular expressions to collect multiple specs. So I don't really want to link every single spec like you would do in a JUnit test, but you want to say, okay, now I want to run all the specs in the package specs. So I will just write in regular expressions, so it needs to be in the package, and you write the regular expression over the fully qualified name of the spec. So basically this one is specs, and then followed by arbitrary characters. And if you keep the cursor over it, you will see which specs are resolved by this expression. And I can, again, run this as a normal JUnit test, and you will see it will execute everything, and it's really it gives a good overview over your application. Now, you can also structure your test suite a little bit more. What I really like to do is I separate my tests into some that track the progress, which are okay to fail, because when they pass, it means we are done. And I like to track the other ones as regression. I mean, and these are the ones that actually should always be green. And if I execute it again, we will see that it actually also in the execution has the same hierarchy as we described in here, just by varying the number of hashes in front of the name. But you can also, sometimes you want to document the structure of your application or something, or of your test suite inside of your suites, and this you can do as well. So basically you can provide an arbitrary description. So this is our application. You can provide formatting, like you do in Markdown. You can add images, links, whatever, and so you can add some here as well. So these are okay to fail, and these should pass. So you might now wonder, okay, why can I format the text in here? Because I mean, it's still doesn't for example, this still isn't shown bold or something like that. And I told you earlier about it. It's another goal is to also be able to generate documentation. And what I'm going to do now is I'm just going to create a new folder, which is called docgen, and make it clean. And then it will generate documentation from our specs. So here's our suite. We have the structure, we have the text in here, now it's nicely formatted. And yeah, we can jump to the generated sources for our feature files, which look really good, and it's a really great way to share your current state on your, with your stakeholders. And you also get generated documentations for the unit specs. And we see here's our table, so we have a nice overview of what the syntax is like and so on. So, I mean, this is really helpful. And we can even further extend it. So, for example, in the coffee list parser, if I add and comment here, so this is not perfect yet, but works for now, then save and go to here, and it will show you the text here. So you can actually build documentation from here. So, and this is what we did with Jnario. So we completely bootstrap Jnario, so all our tests are written in Jnario, and the complete documentation is generated from specs written in Jnario. And we see here we have a more sophisticated example. You can use images, code blocks, and we see it will take the specs you're writing as code examples here. And if you're curious what it looks like, you always click on the source tab and you see the corresponding spec, how it is actually implemented, which is, I think, a really helpful feature. And the lazy person I am, this really saved us a lot of time. Okay, so, but now I want to show you a little bit more, a really cool feature which is I've just finished implementing. So it's not available in the release yet. So I will open the pre-prepared solution for this one. And yeah, so what I want to show you is you can also use Maven to build the application. And yeah, so it's not completely independent of Eclipse. So I quickly run the Maven build script, and it would compile the Jnario sources, run the tests and everything, and it will also generate the documentation. And if you look here, the cool thing now is that it includes the state of our execution inside of the documentation. So in this example it's the same test suite from before, but you will see, okay, all of these pass during the execution. And yeah, I can quickly like make this test fail. So we go here to the coffee tracker and remove this one and just return -1. Run Maven again, and now what it will do is it will directly integrate the reason why a spec failed into the generated documentation. So it's a really great way to share the state of your current implementation with your stakeholders, especially if they're here not programmers. So again, we have to wait for the Maven, and okay, we are done. And now we see everything is red. We see down here which of the specifications failed. For example, here the background passed, but the second scenario passed, the first one failed, and we see the reason why it failed during the execution. Yeah, so this is basically, and we see here, I stole the coffee image from the extent guys. I hope they excuse me, but you see you can really create more really sophisticated documentation with it, and it's always executable. So your examples in your documentation will always work, which is such a good feature, because at least it happened numerous times to me that just my documentation got outdated and people were complaining because the examples didn't work. So I can really recommend doing it this way. And it's less work, which is also a good thing, I guess. Okay, so yeah, coming back to our presentation. What we've seen so far is, I mean, you can create, I mean, if you know Cucumber, so basically the feature syntax is like the same as Cucumber, and which is a really successful project in Ruby project, but you also can use it in Java. But we have added a little twist, so you can directly add your implementations in there, which makes it writing these features a lot faster and quicker than if you use Cucumber. So on the other hand, we can write unit specifications. I didn't show you this, but you can create hierarchies inside your specs. So in this case, I describe a stack, and then I describe different contexts. In one context, it's empty, and the other one is not empty. Because this way, your tests or facts become a lot more expressive, and you remove duplication, because otherwise you would need to write, okay, stack, when empty, then its size should be null. When it's empty and pop, it throws an exception. But now I can pull out this context and remove the first prefix from my name up, which is, again, a really helpful feature. The other thing is it's completely 100% Java compatible, because we use Xbase, which uses the same type system. And we generate normal Java source files, so it's really easy to integrate into your automated builds and so on. So this is like makes it really good choice for normal plain Java projects. And on the other hand, the test suites are really helpful, like because they're so quick. So if you just want to simply run all tests, write a single rectal expression .star, and it will run all the specs in your project. And again, the documentation part is really helpful. For example, creating tutorials or things like that. Really good. So if you're interested, check out the homepage. It's jnario.org. And it's open source, of course. The code is available via GitHub. So if we are happy to receive any contributions. If you want to stay updated, follow us on Twitter. But besides that, I would say, yeah, thanks for listening. And are there any questions? The question was whether there are any plugins for Jenkins to show the generated documentation in the build overview page. So, I mean, actually, you don't need a plugin. So you just use Surefire, for example, to run your tests. And then there's a Maven plugin to, like, show arbitrary HTML, static HTML files. You can just use this and point it to the folder where the generated documentation is. Yeah, I would say. Yeah, of course. I mean, the question was whether we can mix old-style JUnit tests with the Jnario tests, and yeah, definitely, it absolutely makes sense sometimes. Like in certain situations, you really need to like go to the boundaries of JUnit, or you need to create a custom runner or something like that. In that case, it's completely fine to create a normal JUnit test or to mix them. So we are also doing that in our own development.
Can we use custom runners with Jnario? Because, for example, for UI testing, we use runners that take screenshots like videos.
Yeah, this is the question was whether you can use custom test runners. This is at the moment not possible. So because we have our own runner. But one thing is, I've looked at quite a few scenarios where you need to use custom scenarios. Usually you can replace them by extracting the setup teardown logic and things like that. And we have a different way you can do this for Jnario specs. So for example, for Spring, it's possible to use Spring. You can easily replace the Spring runner to make it also Jnario compatible. So I would say in quite a few cases, it's possible to just replace the runner. But we also thinking about providing a way to also provide your own runners. Yes? Yeah, of course. So the question was whether you can mix Java and extend classes. This is no problem at all. So basically, we usually do this. I mean, like certain contexts I use extend, sometimes not. So this is no problem at all. Yeah? The question was whether whether we know different solutions for other languages like Objective-C. I mean, I would say most languages now have a framework which is quite similar to Jnario. I mean, I know that you can execute, for example, cucumber specs in Objective-C, but Jnario, for example, probably won't be ported to Objective-C, but there are definitely frameworks out there for most languages which provide almost the same functionality. The question is how the process works when you're using Jnario to create the specifications and who is actually writing these. So for the unit the specs on unit level, I would say these are your developers write these. And I mean, this is actually like, you can use this, or whoever should use it who uses JUnit right now, because it's a complete replacement. For the features, it's an interesting question. Like, theoretically, in a perfect world, we would have stakeholders who would be who are keen to write these scenarios, but this is, in my experience, not really true. So I would say, and actually it's also not really the goal. So basically, these features, the goal is to use them together with your stakeholders as a way to discuss what you actually expect from the system. So I would recommend that still a developer or like someone in your organization which is like has a programming background writes these scenarios, because you still need to know things like removing duplication, things like that. But you definitely should sit together with your stakeholders and create it together with them. And this is actually what I think works really well.
Do you use Jnario, for example, end-to-end testing, UI testing, like with stuff like Selenium?
The question is whether we use it for end-to-end testing. I mean, I personally don't have a web background, so I don't have any experience with Selenium, but we are currently working on an example for Spring with Selenium and everything, so I don't see any reason why it shouldn't work. And we, for example, in the Eclipse context, we definitely use it for end-to-end testings. For example, things like you run an Eclipse instance, create a project, create a file, do a certain change, and then assert that, for example, a file is generated or something like that. So on this level, we definitely use it, and yeah, it's only possible. Another question? Okay, so thanks again, and give it a try. Honestly, I can say it's awesome. I mean, of course, I'm a little bit biased, but really, I've been using it for a year now, and I can't really imagine going back to JUnit.